Example number 6 says a rock is thrown straight up with a speed of 15.4 meters per second, ignoring air friction. What's the velocity when it hits the ground? What's the total time of flight? And what was the maximum height reached by the rock? Well, one of the keys to this question is that, of course, because the object is moving straight up, then, of course, it's going to reach a certain height before it starts coming back down. The distance that it goes up has to be the same as the distance that it comes down. And the acceleration going up is the same as the acceleration coming down, 9.81, and therefore the time of flight going up is the same as the time of flight coming down. That leads to one last conclusion, and that is whatever the initial speed was at the bottom, that's going to be the final speed when the rock hits the ground down the road. All right, so if the initial velocity was 15.4 meters per second up, the final velocity will be 15.4 meters per second down. And that's the answer to A. There is no real mathematics, but just a logical sequence of arguments. That means if the speed was 5 going up, it's 5 coming down. If it's 15.4 going up initially, then it's 15.4 coming down. Now what about calculating for the time of flight? Well, now that we know that the initial and final velocities are 15.4 positive and negative, and acceleration is 9.81, time of flight is quite basic. So if the initial velocity is 15.4 meters per second and acceleration is negative 9.81 meters per second squared, and we have argued that the final velocity is negative 15.4 meters per second, then of course to calculate the time we look at our 4 kinematic expressions. A is equal to Vf minus Vi over T seems to be the logical choice, because then T is just equal to Vf minus Vi over A. Or in other words, Vf is negative 15.4 minus 15.4 divided by 9.81. Now a lot of people make the mistake of looking at negative 15.4 minus 15.4 and thinking that's equal to 0. It's actually not equal to 0, it's equal to 30.8. Alright, so the change in velocity from the time it left the ground, which was positive 15.4, to the time it hits the ground, the change in velocity was actually 30.8. If you divide that change by the acceleration of gravity, you get 3.14 seconds as the time of flight. All right, so 3.14 seconds is the time that that rock is in the air. To calculate the maximum height, you have to remember that if it leaves the ground at 15.4, it goes up to a certain height, then it comes back down. The height at the top, or sorry, the speed at the top, V, is going to be equal to 0 here. So what you could do is you could say, well, the initial velocity is 15.4 meters per second. The final velocity at the top is 0. All right, we know that it's 15.4 negative coming down, but at the top it's 0. And of course the acceleration that's causing this change is 9.81, and we can calculate what the displacement is. And so using Vf squared equals Vi squared plus 2AD, solve for d, it's equal to Vf squared minus Vi squared over 2A. And this is where all that formula manipulation comes in handy. It's equal to 0 minus 15.4 squared divided by 2 times negative 9.81. And we get 12.087 meters, or in other words, the maximum height, if we go to 3 sig digs, is 12.1 meters. And that would be your answer. The maximum height reached by that object is 12.1 meters. So to answer A, B, and C, if it went up at 15.4, it comes down at 15.4. The time of flight, as we calculated, 3.14 seconds, and the maximum height is 12.1 meters.